Hi Year 10, welcome to today's lesson. Today we're going to be covering the quadratic formula. Now, as I've mentioned over the past few lessons, we've been looking at how to solve quadratic equations, and as we've discussed, there are three methods, and they escalate in difficulty, meaning that the first method is the easiest, and the last method is the hardest. And so we've already covered how to solve quadratic equations using factorization, and we've also looked at completing the square. And today we're going to look at how to use the quadratic formula, which is your last resort. Let me mention that we only use the quadratic formula method if the first two methods fail. Okay? So always try to factorize first. If you can't factorize it, maybe try completing the square. And if you can't complete the square, then use the quadratic formula. So let us begin. So here is the quadratic formula. It says that we've got x, which represents the solutions, by the way, is equal to negative b plus minus the square root of b squared minus 4ac over 2a. And this crazy looking expression here will give you the solutions to a quadratic equation that has coefficients of a, b, and c, as you can see here. Okay, so these letters in the quadratic formula, b, a, and c, what do they mean? They are the numbers in front of x squared, x, and the number out the back. Okay, so that's where a, b, and c come from. Now let me show you how we actually use the quadratic formula. So let's just say you open up your textbook or the test and it says, find the exact solutions, because remember, that's what we're trying to find. We're trying to solve the quadratic equation, finding the solutions, using the quadratic formula. Okay, so it's telling us we have to use the quadratic formula. So as always, let's do part A together and write down the question. That should always be our first thing we do. And let's also write down the quadratic formula. And I think it's always useful to always write it out so that you will never get mixed up of where things go. So let's think about what a, b, and c are in my quadratic equation. If you look back up here, a is the number in front of x squared. And in this case, a, well, there is no number in front of x squared. Well, actually, it's just 1. There's a hidden or invisible 1 there. And so a is just 1. What is b? Well, b is 5. b is the number in front of x. And what is c? Well, c is just the other number that's left there, which is positive 3. So c is 3. And what's really easy about the quadratic formula is that now all we need to do is substitute all those values in. And so wherever I see b, I'm just going to replace with 5. So I'm going to write, well, I'll get minus 5 plus minus the square root of 5 squared minus 4 times 1 times 3 divided by 2 times 1. And of course, as you can see there, I can actually simplify a lot of what's going on. So I've got minus 5 out the front here, plus minus the square root. Now inside that square root, I can simplify, right? Because 5 squared is 25. And I've got 4 times 1 times 3. That gives us 12. And 2 times 1 on the bottom, well, that's just 2. And then I can keep going. 25 minus 12 is actually 13. And of course, we divide by 2. And then this is where I stop, right? These are the solutions. And you're probably thinking, but sir, that just looks like one solution. You said solutions. Is there more than one? Well, actually, if you look closely at this expression, there are two solutions. Can you see where two solutions are? It's actually hidden in this plus minus. What this means is x is equal to minus 5 plus root 13 divided by 2, or x is equal to minus 5 minus root 13 over 2. And so that plus minus actually gives us two solutions. Okay? As you can see here, we got to take the positive case, right, plus, or we take the negative case, where it's a minus. Okay? So here are my two solutions, and generally it is good habit to draw a box around your solutions so the marker knows that they are the solutions that you've found. Okay? So I'm going to also help you do B, because B, as you can see there, is a non-monic, yeah? Because it's got a 2 in front of the x squared. So let's do that together. So let's write down our question. And then let's also write down our quadratic formula. And feel free to pause this video at any time if you need extra time to write things down. Now let's think about what A, B, and C are in this quadratic equation. So A is the number in front of x squared. So A is 2. B, you've got to be a bit careful here because B, it's not 2, it's actually minus 2. Okay, so you need to actually include that minus. And same thing with C. You see that C is actually not 1, but it's actually minus 1. So now we have all the necessary information. We're going to substitute A, B, and C into our quadratic formula. And so let's do that. We've got minus of minus 2, so be careful with the minuses, plus minus the square root of b squared. So b is minus 2, so let's do minus 2 squared, minus 4ac, so 4 times a, which is 2, and c, which is minus 1. And this is all divided by 2 times a, which is 2 times 2. And of course, let us simplify. That minus minus 2 becomes a positive 2, plus minus the square root of 4 minus, so 4 times 2 times minus 1, that is minus 8. So 4 minus minus 8 over 2 times 2 is 4. And so let's keep simplifying. We've got 2 plus minus the square root of 4 plus 8, right? Because minus minus. So we get square root of 12 over 4. Now, am I done? Well, again, you might be thinking, well, let's write out our two solutions. Well, actually, is there something I can continue to simplify? Can I simplify this surd? And hopefully you're thinking, yes, I can, right? I actually can simplify that surd because there is a square number hidden inside that surd. What is a square number that is a factor of 12? 4, right? And so when that 4 is factorized out of that square root, what do we get? We get 2 plus minus 2 square root 3, 2 root 3, right? And so I can actually simplify that a bit further because I now see that this number here and this number here, they're both, and also the denominator, they are all factors, they all have a common factor of 2. And so I can divide everything by 2, so I've got 1 plus minus root 3 over 2. Yeah, so I'm just dividing top and bottom by 2. And now I can write my final solutions. X is equal to the positive case, so plus root 3 over 2, or x is equal to 1 minus root 3 over 2. Now let's quickly talk about the discriminant. You're like, sir, wait, there's more? Yes, there is more. So as we've been working with the quadratic formula, hopefully you've noticed that there is this square root inside the quadratic formula. And inside the square root is b squared, right? b squared minus 4ac. That stuff underneath the square root is what we call the discriminant. Yes, it has a special name. And the symbol that we use for the discriminant is delta, which is a triangle, essentially. But we call it delta. Now, why is this so important? Why do we care so much about this thing underneath the square root? Well, it turns out that depending on what the discriminant is, it will change, not the solution, it will change the solution, but it will change the number of solutions I get. And so you're probably sitting there wondering, what do you mean, sir? I thought quadratic equations always have two solutions, right? You said that, you know, the power is 2, so there should be always two solutions. Isn't that right? Well, actually, not quite. They don't always have two solutions. They can have a maximum of 2, but sometimes some quadratic equations can have one solution. And I think I've done an example with that, but sometimes quadratic equations can have no solutions at all. Okay, so let's have a look at how that can be. Let's say you're doing the quadratic formula, you figured out what a, b, and c are, and you're substituting them into the quadratic formula, right? You're subbing it in. You're like writing out, oh, b squared minus 4ac and all that stuff. And it turns out that b squared minus 4ac, when you sub it in, it's actually positive. It gives you a positive number. It's greater than 0. And that's the case of the two examples that I did up here, right? Do you see underneath the square root we got 12? That's a positive number. And the other example we did, I think we also got a positive number, right? And so if the discriminant, if the stuff underneath the square root is positive, how many solutions do we get? We get 2 solutions. Well, okay, sir. I see what you're saying, right? So what happens if the discriminant is, let's say you sub it all in, right? And instead of getting 12 in the last example, we got 0. Well, what's going to happen, right? So let's actually do a quick demo. Here's the quadratic formula, plus minus the square root of, and let's just say that inside the square root, I get 0. Because that's where the discriminant, I get 0. Right, 2 a's on the bottom, right? Well, plus minus 0. Well, root 0 is just 0. And so I can just write it like this, can't I? Plus minus 0 over 2a. Well, plus minus 0 doesn't do anything to the top number, right? It's like saying 2 plus 0. Well, it's still 2, and 2 minus 0, still 2. And so it turns out that we only have one solution. And that only happens, we only get one solution if the discriminant equals to 0. And the discriminant is the thing, or the stuff, inside the square root. Now, of course, we've done greater than 0, we've done equals to 0. Hopefully you can guess what's next. Less than 0. And so if the discriminant is less than 0, wait a minute. So you can't have a negative number inside a square root, is what I hope you're thinking, right? Because the discriminant, remember, is the stuff underneath the square root. And so if the discriminant turns out to be negative, you can't square root a negative number. It's impossible, right? Imagine if you were writing the quadratic formula, you're trying to find the solutions, and you go plus, minus, square root, like negative 2. And you're sitting there, you're like, well, that doesn't make sense. You would be right. It doesn't make sense, right? Because if the number underneath the square root is negative, guess what? There are no solutions. No solutions at all. Okay. And that is the beauty of actually the discriminant itself. It tells us exactly how many solutions a quadratic equation will have without even having to find the solutions themselves. So let's actually see a question to apply this knowledge. So here we are. We've got a question that says, determine the number of solutions to these quadratic equations using the discriminant, right? The discriminant is b squared minus 4ac. So notice there that it doesn't want us to solve. Notice there it's not asking us to solve the equations. Don't find the solutions. Don't solve them. But rather tell me the number of solutions. So they can either have 2, 1, or 0. Okay? So let's begin. Let's have a look at the first quadratic equation there. And again, let's do our hard work of figuring out what a is equal to. A is 0 there. Oh, sorry, not 0, 1. B is 5. And C is minus 3. Right? We've got to include the negative sign. Now, what is the discriminant? The discriminant is b squared minus 4ac. So let's substitute our values in. We get 5 squared minus 4 times 1 times minus 3. And so we get 25 minus 12. We get 37. And 37 is definitely a positive number, right? 37 is greater than 0 because it's positive. So what happens when the discriminant is greater than 0? Well, if you scroll up a little, yeah, you can see that we get 2 solutions. So how many solutions are there? There are 2. I haven't found the solutions yet. I could if I wanted to, but I know that there must be 2 solutions. So I'm going to let you have a go at B. I'll do C with you. X squared plus 6x plus 9 equals to 0. Let's label what A, B, and C are. A is 1 in this case, B is 6 in this case, and C is 9 in this case. Okay, remember A, B, and C are just the numbers in front of x squared x and the number at the back. So again, let's write down what our discriminant is. It's b squared minus 4ac. And in case you're wondering, yes, you have to memorize that. But I think the formula sheet will have the entire quadratic formula there. And so, of course, if you forget, it's underneath the square root. So now, of course, let's substitute in our numbers for A, B, and C. We'll get 6 squared minus 4 times 1 times 9, which simplifies to 36 minus 36. Ooh, that equals to 0. And what happens when the discriminant is equal to 0? How many solutions will I have? Right, plus minus 0. That doesn't do anything, so I'll just get 1 solution. So therefore, I have 1 solution. All right, thank you, Year 10. I hope that helped, and I will see you when I get back. Bye.